is my email address, and you guys can send me any email if you want, if you have any questions regarding the course, or if you need anything, any extra documentation, I can provide it to you guys. Okay. So I'll have my email typed here so that everybody can see it. And any documentation you guys need, just simply send it to me, send an email to me, and then I'll send the documentation. Okay. So let's just cover this chapter. Uh, EIGRP, it's a routing protocol. One of the routing protocols enhanced interior gateway routing protocol. This is the only problem with EIGRP is that this is a Cisco proprietary. When I say Cisco proprietary, which means that it will only work on the Cisco devices. It will not work if you have a Cisco router or a Juniper router or Arista or Ciena or any other router. So this was pretty big in 90s and early 2000. But since the other vendors are in the market, EIGRP is not getting implemented anymore. So that's why I'm just not going to cover and go into detail in this. I'll just browse through it, right? But the ones you should be really concentrating on is OSPF, right? OSPF is really widely used basically across the networking world at this time, right? So in EIGRP came along, as I said, in the 90s, and this is Cisco proprietary. This is the information, more than enough information for you guys to know that this is can only work if you have the Cisco routers. If you have a different vendor router, then it will not work on it. So that's why any network you guys see, I'm sorry, there was somebody typing something. Okay, sorry. Okay, I thought it was somebody typed something. So this was first released in 1992. This is basically also for the routing protocol. And if you can see it here, they are using IPv6 also, but it's not getting implemented anymore. So there are a few things in the main routing protocol. What is basically routing protocol? I discussed it with you guys when I was teaching OSPF, open short path first, right? And what that is basically all you do, you put a network statement in OSPF or in EIGRP and only advertise the network which is basically sitting behind you, right? And then what it will do, it will propagate and it will send it to the neighbor and saying, if you guys want to go to this network, simply send the traffic to me. Before, when we were using static route, what was happening was we had to manually go in and configure that in order to get to this destination network, send it to my next hop or my next router, whatever that router is, right? But in EIGRP and OSPF, you don't have to do that. All you have to do is just configure your own interface and configure the network which is sitting behind you. When I say network sitting behind you, means on your switches, LAN switches, like you have like VLANs and all this kind of stuff, right? We talked about the VLANs. That's all you have to propagate, and you're done. Understood? So this is EIGRP hello update query reply and acknowledgement. What this is, even in OSPF, you have this. What it is basically, in OSPF, when we talked about it in the last class, what it is, it sends a hello and say, you know what, are you up? Are you there? Am I speaking the same language as you are? If both ends are OSPF or both ends with EIGRP, they're going to send in hello to each other. Update is basically when they start to send each other's the information, right? Query is basically if a network has gone down, so it will send a query out to the neighbors and see, hey, is there any other way I can get to this destination network? And then you get a reply and acknowledgement. So basically, it's kind of a handshake. A query is basic. Just remember, query is basically when if the network is out in your from your routing table, you send a query out to other routers and see if you have a path to it. Do you have the path to the destination or not? Right? Neighbor topology and routing table. You got to understand this. Routing table is the only thing which router looks at in order to decide whether he knows how to get to the destination. Understood? So the routing table is the only table router looks at in order to decide whether he knows how to get to the destination. If it's not in the routing table, the router will simply drop the packet, no matter what routing protocol you're running on it. But what EIGRP does, what it does, it keeps two tables. One is the neighbor topology table, neighbor table, and what it does, and there is something called successor and feasible successor. So the successor is basically in order to get to the destination. So I'll give you an example over here. This is in order for Vancouver to get to Montreal, there are two paths for him. Either he go to Toronto and then he goes to Montreal, or he goes directly to the Montreal. Understood? So basically, if he takes this path, a direct connection between Vancouver and Montreal, then what it will do is going to say, okay, I'm going to put this in my routing table. But in my topology table, I'm going to have this route also from Vancouver to Toronto to Montreal. If this path goes down, EIGRP is smart enough and says, you know what, okay, I've taken this path because this path is down, this connection is down. What I'm going to do, I'm going to take from my topology table, I'm going to put it in my routing table that I also have got a backup path. So this routing protocol does everything for you. You don't have to do it. It does it for you. Understood, guys? Yes, no? How many people are out there? 1, 2, 3, 4, 5, 6. Okay.
Yep.
Okay. All right. There's a pretty heavy yep, you know.
No, even Imtiaz bhai, even if you don't see many people here, some people go for the recordings also.
You know, I was just asking, a question to see if anyone has any
Yeah.
question. I wasn't sure how many people are out there, right?
Yeah.
So
Okay.
that's why I was just saying, can you repeat? Somebody said something here. Can you repeat it once again? What part, Almas, you want me to repeat? I'm sorry, I missed it at 7-Eleven. So what part, Almas? There are a few things I explained. Can you type it? The routing table. Okay. Almost routing table is the one which router decides upon to see how it will get from source to destination. If a path is there in this scenario, this Vancouver, if it wants to go to the Montreal, he will have two paths, right? One directly from Vancouver to Montreal, or he will go from Vancouver to Toronto and Toronto to Montreal. So if he has this as a primary path and this as a backup path, so what EIGRP will do, he's going to say, my friend, if this is my primary path, I'm going to be putting this in my routing table, right? And this I'm going to put in a topology in the backup table. If this path goes down, then EIGRP is smart enough to take it from your topology table and it will put it in the routing table. So the router can decide, because even if it's in the topology table, it's useless for the router. The router is not going to be going into the topology. Router always makes a decision whether it has a route to the destination by looking in at the routing table. That's it. Punto. Understood, Almas? You got it, my friend? Okay. So that's what this means. So diffusing update algorithm, do not age routable entries. Periodic updates includes best path, loop free backup paths. I'm going to explain all that. Faster conversions, unequal cost load balancing, partial, bounded, and basically so PDMs to support different layer 3. So what they are trying to tell you here is, if the route is there, if let's suppose, give an example, if this path has not gone down in this, for Vancouver to go to Montreal, he's going to be taking this path, right? And then he says, you know what, I'm going to put this path in my routing table. If any of my guys over here in marketing or accounts wants to get to IT department or PC department, he can take this path as the primary path. So he's going to be putting it in the routing table. Agreed? This is what I explained earlier. Now, if this path does not go down for the next 3 years, this path will always be in there. It's not going to be changing anything. Only the changes will occur is when basically, so I'll give you an example. So if you look at this, if I look at show IP route is basically, this is how many minutes ago did I learn this? How many seconds ago did I learn this network? How many hours did I learn this? How many years and days I have seen that says 2, 3 years, 4 years, 5 years, 6 years. In OSPF I've seen also, in BGP I've seen also, in EAGRP I've seen also. Sometimes if the network has not gone down or the connection has not gone down, so it will say that I've been up for 2 years or 3 years, or days or hours. Understood? So that's what this is trying to say, that it's not going to be changing the whole route, because you see, RIP is one another routing protocol which we don't use anymore, right? This was in the beginning. What it does, after every 15 minutes, it it sends the whole routing table to its neighbor. But this was at the beginning. The routers were not that busy. And once the thing started to come up on the routers, they said, okay, you know what? We can't afford RIP to have it there, because RIP is also a problem that if it gets to the destination on 15 hops, fine. On the 16 hop, the packet is going to get dropped. So that's why they came up with OSPF. That's why they came up with EIGRP, ISIS, and BGP. These are the different routing protocols in basic in the networking world we use at this time. So the neighbor table, next hop router, topology table, routing table, basically. So that's what I'm saying. That's what I was just explaining earlier, that these tables are created by having a backup path. One is the primary and one is the backup. Primary goes into the router, the backup goes into the topology or a neighbor table. Understood? If the primary goes down, then EIGRP is smart enough to take the backup path and then puts it into the routing table. Please increase the font for the visibility. This font is not enough. Is this okay? Yes.
Excuse me. So do backup table only contains the backup protocol or the
No,
routing
no.
information?
Backup path,
The
not
backup
backup
path.
protocol.
Yeah, the backup path.
Yes.
Um, is it has to be or is it can be sync in between primary and the backup?
Can you repeat that? The
So what
last
I'm
part.
saying, yeah, so what I'm saying is, so primary only contain the primary path information, right? And the backup contains only the backup information, or it has a delta in
It
between,
has a backup path only.
only the backup path.
Yeah, because you see, the primary path it is putting into the routing table, right?
Right.
The primary connection is putting into the routing table, and the backup is basically putting into the backup table. And what EIGRP does is smart enough to know, you know what, my primary is out. So I have another way to get to this destination. I'm going to be putting it into my routing table. So what he's going to do, he's going to start traveling from Vancouver to Toronto and then from Toronto to Montreal. Okay, got it? Yes, no, could be, might be.
Sorry, I wasn't mute. No, if I throw a scenario here, let's say if at any given point the connection between Vancouver and Toronto was dropped,
Hmm.
it lost the routing table information. Now we have a situation when the Vancouver and Montreal got dropped off, so there's no backup table information as well.
With this diagram, no, there is none.
Okay.
There is none,
So
right?
what do we do normally for this kind of a fault tolerant? Do we do
Well,
multiple backup tables?
no, actually, we see what happens. The networks are so big, you probably have 2, 3 connections going to do different routers. If all connections are failing, then you're in deep waters, right?
No, I'm saying that I'm talking about this particular destination, let's say, is between Vancouver and Montreal. Let's say if there is a Vancouver and I don't know, give me a city here, Alberta.
Mhm.
So the Alberta would have their own backup routing table and own primary routing table.
Yes, because you see
Correct?
what happens is in the GRP, it every router calculates what is the bandwidth, what is the delay, right? Higher the bandwidth, lower the cost. So basically, it will look at how much is the bandwidth, how much is the delay for me to use this as a primary or this as a primary. This connection between Vancouver and Montreal might be like only 500K, but here to here, from here to here, is might be 10 meg. So obviously he's going to be using this path because this is a lot faster, right? And this is going to be used as a backup path. Now, if you are in your scenario, what you're saying that you have Alberta. If Alberta is also connected to any of these routers, then this Vancouver is going to try to, what's going to happen is, let's suppose your primary goes out, right? And he uses the backup as Toronto. He puts it into the primary. Now he's going to go and look for, is there any backup path for me available in my network? If it is, it's going to use it in a backup file, right? Table. If not, then he's not going to have anything. Understood?
Yeah, no, I get that part. I was trying to understand basically it's about the time to live part. You said that if if the connection never drops, it will remain there for ages, correct?
Yes, it will.
Right. Uh, I was talking about in case of a scenario where we had the backup routing table drop. So there's no sync happening in between primary and backup. Backup only happens
Now, one
once, right?
second. Sorry. When you said if your backup goes out the window, your backup path goes out the window,
Right.
then what it will do, the router is going to try to see if it has any other way to get to the destination, because something happened to the backup path and it's
No, but
out the door.
at this point, what I'm saying, at this point, the primary is still intact. Primary hasn't
Yes.
lost. So backup is gone, but the primary is still there. But if
Yes.
primary gone, then there is no backup left there.
There's no backup, then you're out of luck, my friend.
Okay. All right. Thanks.
Right? Because there is no for it, because you see, just by looking at this, there is no other way for him to get to the destination. Right?
So well, what I'm saying, let's say the backup was out and then backup came back. I mean, the connection is reestablished. At that point, the primary gonna send back the information to this neighbor table or the
No.
backup table. Is gonna update it or no?
No, because you see, he already has a primary connection up, right?
Right.
So whatever path, whatever traffic he's sending through his primary connection. If a backup goes out the window, what it will happen, then it's going to start looking for any other way to get to that network, right?
Okay.
If one of
So
the backup fails.
okay, sorry.
If it,
Sorry, I'm sorry to cut you off. Just quick question before I lose my thought. Uh, so if the connection is established between primary only, at what given time the backup routing table will be established?
what given time means what? You see, let me tell you something. 1 second. Understand this scenario for 1 second.
Okay, yeah.
Understand this scenario first. And it
Mhm.
will probably answer your question. You have Vancouver to Montreal, and there are two paths to it. From Vancouver to Montreal is direct connection, or he goes from Vancouver to Toronto and Toronto to Montreal. Agreed on this point, right?
Yeah, that's
Now,
right.
Vancouver to Montreal, let's suppose goes down. Punto, it's out of the window. It doesn't know how to get to it. The connection has gone down. What he will do, he's going to take his backup path and he's going to be putting it into the routing table and he's going to say, I'm going to start sending traffic through Toronto. Now
No,
what he's
sorry. This is what my question was. So when was this backup routing table established? When was it created?
initially, when it
Initially.
basically starts to send hello to each other.
Oh, I see. Okay.
When you have the EIGRP configured between this and this and this and this, they basically send hello packet to each other,
Okay.
right?
Okay.
And
Got
they
it.
send hello, they send updates to each other. And then what EIGRP does, he looks at it and he says, okay, in order to get to 188, 188, 188, I can either go from here to here, or I can go from here to here, or here to here.
Gonna go fastest route possible, right? That will make sense.
Fastest, exactly,
Right. Okay. Thank you. Got it.
right? But remember, if primary is there, this connection goes down, the backup connection goes down, then what Vancouver is going to do, Vancouver is going to say, hey, is there anybody out there who knows how to get to this destination? Any other way to get to it? Because he wants to fill up his backup table also,
Correct. Yeah.
right?
Right.
But if there is nobody out there, then nothing is going to be in your backup table. And whenever this connection comes back up, he's going to put it back in there.
Right. Yeah, it makes sense. Makes
Okay?
sense. Correct. Thanks.
No problem. So basically in this, there's a hello packet which gets sent. All these routers, as I was just saying, that it comes onto the network, and as soon as they come to the network, everybody sends hello to each other. Once they start to send hello to each other, basically they're saying, I'm EIGRP. Do you speak the same language? Do you have the same routing protocol? Now, if I have in R1, if I have EIGRP, this is OSPF, this is EIGRP, it will not work. It will work, but there is a different command to inject routes into the OSPF and everything. I'm not going to get into that right now. But you all have to be running EIGRP for them to communicate with each other. Understood? You cannot have one EIGRP here and one OSPF here and then, some other, la la land routing protocol. In order for them to communicate, you have to be speaking the same routing protocol language. But there are scenarios that on one router, you are running two different routing protocols. You could be running EIGRP, you could be running OSPF, you could be running BGP, right? But for them, let's suppose he's running EIGRP, he's running OSPF R1, and he's running BGP. This is also running EIGRP, OSPF, and BGP. So it's the establishment of connection is going to be between EIGRP and EIGRP, right? If you want to establish the connection. But then there is a different, more advanced, I'm not going to get into it, that how to take from one routing protocol, the networks you learn, and you inject it into a different routing protocol. It's called redistribution. So you guys can, look it up. This is like a more detailed discussion. So the hello packets are sent when? Hello packets are sent, for 1.54 meg after 60-second, and basically hold time. Hold down a default hold time and dead interval, which is in OSPF in the last class, almost the same thing, right? You can also manually change it. You don't want your routers to be sending hello to each other after every 5 seconds or 10 seconds or 20. You can make it 50 seconds, and then you can make the default hold time 4 times or 3 times, whatever. But you have to make sure it gets, configured on all the interfaces simultaneously. That the reason the whole time is, as I said, explained to you, the dead interval in OSPF is basically if I have not received a hello packet, if the connection is going up and down, and because of the connection going up and down, I'm not getting a hello packet, and my packets are getting dropped. So I'll wait whatever 4 times or 5 times the hello interval, and I'm going to wait till I announce it to the world that I don't have a route to it. Understood? So it depends. Default is 3 times, but you can go in and you can change it. It's up to you. Update packets, basically letting them know, you know, contains only the routing information. A change occurs sent only to those routers that require it, and it's a reliable delivery. When you say reliable delivery, any changes in the network, what networks are sending behind me, I'm going to be sending it to my neighbors. All these guys are going to be sending it to each other, and once they receive it, they're expecting an acknowledgement back. Right? If you, in my previous classes, I explained to you what TCP and UDP is. This is a kind of a TCP reaction. What TCP does, transmission control protocol, if I send you something, I better get an acknowledgement from you. If I don't get an acknowledgement from you, which means that you have not received anything from me. In a UDP environment, what happens if I send you a hello? I don't care. I don't expect an acknowledgement from you. But in this scenario, there is an acknowledgement. Understood, guys? So the query and the reply back, you know, queries and replies use reliable. Hello doesn't use an acknowledgement. So this is, that who came up with this Dijkstra algorithm. So this is just a reply and acknowledgement, feature I've just showed you here. I don't want you, don't get into this, packet headers and everything. What these packet headers are is basically, whatever. Let's suppose if I send you, hello, how are you doing? And if it's going through EIGRP, there are encapsulations on top of the packet, right? What goes on the packet? Source IP, destination IP, source port, destination port, source protocol, destination protocol. If it's going through EIGRP, EIGRP is also going to add a lot of stuff on top of the packet, encapsulate on top of those packets. And once it gets to the destination, it decapsulate, right? Basically, it takes the information out and basically gives it. And remember, I discussed the OSI layer. open OSI layer, in which I said, application, presentation, session, network, data, right, and physical. So basically, every layer encapsulate or decapsulates. So you don't have to get into this. This is basically an extra encapsulation on top of the packet itself. What EIGRP does, it's an autonomous system number. Um, Before I explain you this, I'm going to have to show you what this is, and then you will understand it. So let me show you this, right? So if I look at this, the Toronto, how this gets configured. So if I do show IP interface, everybody can see it, right? And I do a show running config. And let me just do show IP interface brief. This right here, guys, this is what they're talking about, autonomous system. What autonomous system number is, it's a domain. Just like a lot of you guys might know about, the window guys, where they say, this is a domain for Microsoft, and there's another domain, you're logging into your own domain, right? Basically, a bunch of computers, sharing that, that domain information, like for Canada or something like that, right? So in this scenario, this EIGRP is as a domain. Autonomous system number is called. EIGRP router ID, as I said, mentioned also exactly the same thing in OSPF, if you guys remember. This is just a name of the router. Passive interface fast Ethernet 00, recall OSPF, because through this interface, I've got a switch sitting on the other end. The switch does not talk routing protocol, because routing protocol works only on layer 3 devices, which is a router, right? So passive interface means, my friend, do not send any routing updates through this interface out to the switch, because switch does not speak the same language. He's just a layer 2, and layer 2 only worries about the MAC address and the port numbers. Then basically, remember the network statement I said in the routing protocol, all you have to worry about is the network statement. all all this is I'm advertising is what is configured on my router, and that's it. I don't care about what is Montreal is, whatever Vancouver is. So if you look at this, this is my one VLAN 158. This is my another VLAN 30. This is my serial connection, connecting to one to the Montreal and one to the Vancouver. And this is my loopback ID. That's it. And no auto summary. What no auto summary does, it says do not summarize my routes. What they're saying is the routing protocol works on a classful basis. So because having this no auto summary, they say do not summarize it. Make sure you're taking the subnet mask with the route updates, sending it to the neighbors. Understood? So if you look at this, this is exactly what they're talking about here. Router, EIGRP1, which means my autonomous system number, my domain. In OSPF, what we did, area. I said in OSPF, if you recall, I said router OSPF, this number is just a process number, process ID. But then we defined area 0, area 1, right? In our last class, if you remember. But over here, this is what defines what domain you're in. And EIGRP router ID is just a loopback. Loopback is a virtual interface. So they're just showing you how to configure it here. Network statement. This is the network which is sitting behind R2. So where is R2? Right here. And he's saying network 192.168.10. Where is 192.168.10? Here we go. 10.8. Why it's 10.8/30? What does that mean? You're only, remember that guys, you're not putting every single IP address. All you're doing is putting the network addresses. What is a network address? If you calculate from my, I don't know, 4 or 5 classes ago, I explained you guys the IP addressing. What this is, this with 255.255.255.252, this is a /30, and what this /30 means that you got only 2 IP addresses. One is .9, the other one is .10. So that's what they're explaining here. .9 is configured here, .10 is configured here. So you don't put .9 or .10 here. You only put the 8, and router automatically knows that if you have put .8, which means that you're part of that .9 and .10. Understood? So this is just the hello packet discovery, getting a reply back. This is just showing you, hello, I'm a router A. This is no, not router A. It basically the router ID. This is what gets sent. He gets a reply back, sends an update with routing information. He acknowledges hello. You remember, hello doesn't have an acknowledgement. They send an update to each other, acknowledges. They send this routing information and acknowledge and converge. What converge means? Now basically we are in sync. Whatever information I have, now you have it. That's how every router behaves. This is the composite metric. Basically, bandwidth. EIGRP decides on bandwidth, how much bandwidth it is. What is the delay? How much load on the link or the connection from source to destination? And reliable, how reliable this is. Is it been dropping a lot? If it's dropping a lot, then it's not reliable for the connection. And load, what's the basically, let's suppose if it's utilizing 50% or 60% or 70% of the bandwidth, this is what they're talking about.
So what's the difference exactly between bandwidth and load?
Bandwidth is, my friend, you have got 5 meg bandwidth, right? Or a 10 meg bandwidth. Let's suppose you have 10 meg bandwidth. So your bandwidth is 10 meg, but load is you're utilizing 80% of it. You're using 8 meg, right? If it's a 10 meg pipe and you're using 8 meg, which means you're utilizing 80%. Understood, sir? So that's what load is. Load is how much bandwidth you're using. So when we say you use,
yeah, I mean, what I mean is, who decide that part between the band
EIGRP decides it, my friend.
itself to do that? Okay.
Absolutely. Because you see, there's a whole formula here. There's a whole formula here. What EIGRP uses, it uses the bandwidth, it uses the delay, the reliability and everything. There is the whole formula which EIGRP uses and then decides, okay, this is how much bandwidth this is what the load is, and voila, I'm going to be using this path or that path.
Is there any way or any part where they take a precedence, load over bandwidth or bandwidth over load?
So you will have to change the whole, the language of EIGRP, right?
Well, I'm just saying that if it's a calculation, do it. So it just it do it automatically on its own and decide.
It does.
I'll take the precedence at any on any of those, right? Between bandwidth and the load.
I'm not sure. In the last 24 years in the networking, I have never done it. I think the best for you is go and look at RFC. It's basically it's a document where you can put a comment. Those who have come up with this EIGRP, you can put comments in it, and you can also see if you can manipulate the load or bandwidth over there. But what we basically have done, is we put a bandwidth statement in it, and through the bandwidth statement, basically we make sure that EIGRP decides on what. Let's suppose I've got 1 meg defined here, I've got 2 meg defined on this one, I got 3 meg defined on that one. What it does, it takes the MTU. MTU is a maximum transmission unit. So let's suppose I've got a SONET connection between these, and SONET can go up to like 10 meg or 10 gig or 1 gig or something, but the actual bandwidth is only 1 meg, right? So basically what I will do, I'm going to put a bandwidth statement on both ends. So you know what, this is not the MTU of an interface. MTU is maximum transmission unit of an interface. So do not think that this interface, if it's an ATM or it's a SONET or it's a POS, do not take its maximum value and then calculate. So when we put the bandwidth statement in it, we are specifically telling EIGRP and Ospf and BGP that, my friend, do not look at the interface bandwidth total, use what we have put it into the command. Understood?
Yeah.
But how can you use manipulate the delay and bandwidth? You have to go and look at the research paper. There is a research, what is that? RFC stands for comment or something, right? So you got to look at the research paper and see, what they have done there. But in my last 20 to 23 years, I have not manipulated those, so I cannot say anything. I cannot
No,
make a comment.
got it.
Okay.
Thanks.
But look for RFC though. You might find an answer there. Okay. Now, this is your bandwidth and sum of delays into 256. Now, your next question would be, if I have got this whole formula right here for EIGRP, whoever has written the code for EIGRP, this is how they want they want EIGRP to behave in the environment. But you have to look at this. K2, K4, and K5 values are zeros. So the real formula is this right here. Uh, Slowest bandwidth plus sum of delays into 256. The rest all zeros out because of being their values is zero. This is by default. Why? Now, my question has always been, why basically have they put this long formula in there and having the values load as zero, load as zero here by default, load as zero here by default. You might be able to change it. I don't know. I've never changed it. But the thing what I have used is this into 256. But why did they, if this is the main formula after taking all the zeros out, then why do they have to give the whole long formula over here? I couldn't find an answer. You'll probably find an answer in the research paper for EIGRP. Whoever has written the code, you will probably, go and read up on it. Okay. This is the administrative distance, AD. 90 is AD for EIGRP. 110 is for OSPF. 1 is for static, right? 0 is for directly connected. BGP is IBGP is 200. So there are few administrative distance you need to understand, you need to memorize. What administrative distance is basically the trustworthiness. If I am learning the destination network through two different ways, through static and through EIGRP, or through OSPF and EIGRP, then the lower the administrative distance, the more preferred the path will be. So if I'm learning it from OSPF and I'm learning it through EIGRP, then I'm going to be picking the EIGRP because of its AD is 90 right here. This cost here is basically saying in order to get to the destination, whatever my bandwidth is, whatever the delay is on the interface, multiply it by 256. This is the number you're going to have here. So if I look at this example right here in Vancouver, these are basically my numbers. 90 is the administrative distance. This is the delay bandwidth into 256. Right? So now you can go and play with this number if you want to. Right? This is how I'm learning this network, through which interface, through which IP address I'm learning it from, how long ago did I learn it, 12 minutes and 32 seconds ago, and through which serial interface am I learning it from. How I'm going to be going to the destination, through which interface I'm going to be going to the destination. This is what it means. So in EIGRP, there are a few things: successor, feasible successor, feasible distance, feasible successor, reported distance, and feasible condition. Now, successor is the primary path to the destination. So whatever the primary path is to the destination is the successor, and it's going to go into the routing table. Feasible distance is what is my distance calculation with my bandwidth, with my delay into my multiply by 256. So whatever the feasible distance is, whatever the cost is for me. Now, feasible successor, this is my backup path I'm talking about. This is the backup path. Reported distance is basically in order to get to the destination, What is my neighbor telling me? So in this scenario, if you look at it, the reported distance from here, Montreal to Vancouver, he's going to report, my friend, in order to get to 188.188.188.0/24, your reported distance is 20. Right? So this basically your neighbor is telling you what is the reported distance from me to you in order to get to the destination. That's what reported distance is. In a feasible condition, or basically, if your primary goes down, then basically takes your backup and puts your backup into the primary. Understood, guys? So that I didn't put too much information in EIGRP because this is not used that much. This is important. Access control. Any questions from here? EIGRP. Let me see. I didn't look at the. This is fine. I was referring to the diagram. Okay. Any question from here? Okay. Let's jump on access control list. This is very important. You have to understand the ACLs. ACLs is basically the one which tells you, if you understand ACL, it's the same concept as firewalls, right? What ACL does, it says source to destination network, source port, destination port, source protocol, destination protocol, allow or deny. So that's what ACL does. So the ACL is a sequential list of permit or deny statement known as access control entries. ACs are also commonly called ACL statements. Source IP, destination IP, protocols, TCP, UDP, source port, destination port. Simple as that. ACLs are simple. Source IP, destination, source protocol, destination protocol, source port, destination port. Right? Port can be only two kinds, TCP or a UDP, right? So now, inbound and outbound, remember, same concept applies in firewall. Packets coming into the router is inbound. When the router processes those packets, looking at the ACL access list, and then it says, okay, if I've got 2-3 ports for outbound, I'm going to be sending it from port number 2. That is outbound. Why? Because router has to process that packet. Understood this point, guys? So ACLs are two types, standard ACLs and extended ACLs. Standard ACLs, I don't know, we used to use a lot, not anymore. Standard ACL, the problem with standard ACL is only source IP address. Access list 10, permit this, that's it. Only allow the network from sourcing, that's about it. In extended one, we say permit or deny source to destination. So how do you read it? Anything from 1 to 99 is standard access list. Anything from 100 to 199 is extended access list. Extended access list, how you're saying is access list, whatever the number is, permit a TCP connection, 192.168.30.0, and this is wildcard mask, guys. Remember, wildcard mask is the reverse of subnet mask, right? So which means this is a what? It's a slash what? What is this slash?
Is it 24?
Is it? Anybody else, guys? What is this? Nobody's typing. You're right. It's a slash 24, right? 255.255.255.0. And how do you reverse it? You subtract it from 255.255.255.255. Punto. That's it. Right? So they're saying permit this source network to any. Any means any destination. So remember, it's always go in this way. Source to destination. Source to destination. Just remember that. Memorize, drill it in your heads. Source to destination. So here you go. This is what I'm explaining. 1 to 99 is standard. and extended is basically 100 to 199. We just
Brother Imtiaz, could you go back to the slide again to that the command? When it says equals 80, so it means anything coming from 80 or anything goes to 80.
now what it's saying. Remember this: access list always goes from source to destination. Agreed? So far, so good. So what
Good.
I'm saying is access 103 permit a TCP port connection, which is one source network is what 192.168.30.0, 255.255.255.0. Any destination equals 80 on 80 when you connect to it, connected on port 80. And port 80 is what?
Web server, basically, HTTP.
HTTP. And what is HTTPS? 443, right?
443, yeah.
So this is what it's telling you: source network to destination. In this scenario, your destination network is any. This is your source network, and this is your destination network on port 80.
So basically, we are allowing any traffic coming from network 30 to our any of our web server listening on port 80.
What you're saying
With
is
regardless of
allow
IP, right?
allow this network to connect to any destination network on port 80. That's it. Understood, my friend?
Right, yeah, got it.
Now, what does this mean? Access list 1, permit any. And what is the problem with this? This is a standard. Either I do this 0.0.0.0.255.255, or I just say permit any network, any source network. Because why? This is a standard one right here. So this is the example. Either I write the first line or the second line is the same thing, right? Or I write like this. First line and second line is exactly the same. Why? Zero, because remember, guys, this is the wildcard mask. Wildcard mask is what? The reverse of subnet mask. So if it is 255.255.255.255, which means he's only talking about a host, there is no range or anything like that, right? So if you do a wildcard mask, you have to subtract it from 255.255.255.255. It was going to give you .0.0.0.0, right? So either you put this or you put this access list 1, permit host, this, allow this host. That's it. And remember this, guys, there is always an invisible line at the bottom, even if it's not defined, which means it's deny any. Only permit this and the rest gets denied. It's automatically there, which you don't see. Same thing applies for the router. Same thing applies for the firewall. Okay. Now, because the problem with the standard is, if you're going to permit or deny a standard, it's going to block everything from here going out. So that's why they say standard as close to the destination as possible. So let's suppose if you're trying to block this 190.168.10.0 going to 192.168.30.0, if you deny it here, what would happen? He's not going to be able to go to these networks sitting behind R2. So that's why it's better to deny it here, that any packet comes into this R3 from 192.168.10.0/24, deny it. Permit anything else. But if you would have denied it here, what would have happened? This traffic would not have gone to R2. So that's why the standard, you have to define it as close to the destination as possible. Extended, you can put it as close to the source as possible. Why? Because in standard, guys, what we do is this puppy. In extended, you're basically giving the network source and telling also the destination. Over here, you're only giving the source. If you are already telling him not to go, if you're saying IP access list 101, deny 192.168.10.0, 255.255.255, destination network 192.168.30.0, you know, basically 255.255, then what you can do, you can put it here. So any packet comes in from here, going to 30.0, he's going to block this puppy right here. Any packet comes from here, tries to go to 192.168.31, he's going to block it right here. But if any of the packet which tries to go to anywhere else, he's going to let it go. Understood? So the reason we do it here is because we don't want to waste the bandwidth of this guy. We don't want to take its bandwidth over here. We don't want router to process, because you see everything in router processes, it goes into the memory, goes into the CPU, and then it has to check it out, right? So that's why we don't want to waste those bandwidth and spike up the memory and spike up the CPU.
Is it gonna block 31 as well?
Yeah, you'll have to block 31. If you don't want 31, you don't want 191.168.10.0 to go to 31, then you will have to block it. If you
No, I'm
only want
saying
to,
that if you don't block 31, it will still go through though, right?
yeah, exactly. If you block only 30, then it will only be basically going in, but only going in for 31. But it
Right.
would get blocked over here going for 30 though.
Right.
Understood?
Yeah.
So this is just how to create the standard. So let's look at this. Rather than this example, I'll give you this example. I'll explain you here. Access list 1, permit 192.168.10.0/24, guys. Right? And you don't have to do this. This is exactly what I was saying. Don't do this. If you want, you can do it. But this last line is same as this one. Why? Remember I was saying earlier that if you don't put anything, there is an automatic deny at the bottom, invisible. So even if you do this or you don't put it, it's the same thing. But it's good to get in the habit of doing it. So what this is saying is, if any packet comes from 192.168.10, block it. Either if you want to block it here, or if you block it here, if you block it here, what would happen? Let's suppose you want 192.168.10.10 to access the connection out. Let's suppose this is the internet. You want him to go to the internet, but you do not want PC1 to talk to PC2, right? So if you block it here, what would happen? He's not going to be able to go out to the internet also. So you basically block it on this interface saying, deny this 192.168.10.0 coming here. Now, looking at this scenario, which one is, just by looking at this access list 1, right? And let's suppose this access list 1 is defined here on serial 00, which is going to the internet. Now, let me ask you something. Is 192.168.11.0/24 be able to go out on R1? Let me see if you guys are sleeping or awake. By
Yeah.
looking at,
I think no.
okay, why do you think no?
Wait, can you repeat the question again? Once?
My question is, my friend, is if this statement, by looking at this statement, and I put the statement on serial 00, would the 192.168.11.0 be able to go out from the R1?
No, it wouldn't be. Yeah.
No.
Right?
Yeah.
By
No,
default, they all deny, right?
because
Yeah, because
exactly.
if you don't want PC1 to contact PC2, so you're gonna have to block the internet for PC2 to
Yeah,
deny.
yeah. But my question, my friend, is if I have this statement and I put this statement here on R1 and I say, going out, would 192.168.11 be able to go out from R1 to the internet? R1 has an internet connection. Agreed? On 000. If I put this statement here on 000, would 11 be going out to the internet or not?
Well, the answer is no, right? Yeah. I don't know if I should be saying.
I'm sorry?
Yeah, it cannot because by default they'll deny.
Okay. But can PC1 and PC2 talk to each other?
Yeah, they'll be able to talk to each other.
Right? If I put this statement here, which means I'm only allowing 10.0/24 to go out, but because of this invisible deny at the bottom, 11 will not go out because the statement is here. But 10 and 192.168.10 and 192.168.11 will be able to communicate with each other, no problem. But only the problem would come when 11 will be trying to go out from this. Right? That's it.
11
Now,
can talk to 10, you're saying, right?
11 and 10 would talk to each other. Am I right? If I have this statement configured on 000, would 11 and 10 talk to each other?
Yes, they will.
They will, because my statement is configured here, my friend. 000. Only deny is 11 network going out here because of
So
this.
that is only for the outside traffic, not for the
Yes, my
internal.
friend. Exactly.
Okay,
000 is going out.
okay.
Okay. Now look at this statement. Where is the problem with this statement? Look at this. He is denying. And remember, I said initially that ACLs are sequential, which means line by line by line by line, right? It looks at the first line, then if there is no match, it goes to the second, no match, goes to the third, no match, goes to the fourth. Now, there is a problem here. What is the problem here, my friend? This should go on top and this should go on the bottom. Why? Because look at this, 192.168.10.0/24. And what is the range? 192.168.10.1 to 192.168.10.254. So this puppy falls in this range.
Okay, this host is part of the same network. And if you deny it first, then this won't work that, right? That's the idea.
Exactly.
Got
Because
it.
it's sequential, right? So the router looks at the first statement and says, deny the whole 10.0/24 network. He's going to deny it. But there is a permit statement at the bottom. He's not going to go to the second one because router looks at the sequential, number wise, top to bottom. Understood, guys? So this basically access list becomes access group 1 out. So whenever you go under the interface, it becomes an access group. Access group means the same thing as access list. God knows why they, make life easy. Instead of access group, put access list 1, for people to understand. Okay. Now here, what is the problem? Blah, 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 deny, permit. What is this saying though? What is this saying? What this is saying, deny only 10.10 network. Anything with 10.9, allow it. And then there is another deny at the bottom, third line, which is invisible. Also, 11 is going to deny going out. Understood, guys? So this is IP access list standard. This is basically the naming convention. So how do we, I'm going to explain this in the configuration mode. When I configure it, the whole thing here, I'm skipping these 2 pages because they're explaining this in these 2 pages over here. So it's going to be a lot easier for me to explain you this than these lines over here. So what they're saying here, this is the naming convention, right? In the naming convention, instead of access list standard, you put IP access standard, and then you put a name here. You can choose anything you want. You can choose any name. So because once you have configured something, you have gone home, somebody else has come in and he's trying to troubleshoot it. So as soon as he sees this name and you say, oh, okay, this is for this network. Oh, this is for this network. Oh, this is for marketing, or this is for, finance department, whatever name you want to put it in for easy troubleshooting for others, you put that name in. It says deny host 192.168.11.10, permit anything else. Only deny this puppy to go out and anything else. Exit IP interface gig00, which is where is gig00 here, and IP access group, no access out. So what this is saying is as soon as this 11.10 comes in here, deny this puppy. Anything else, 11.11 or 11.12 or 11.13, allow it. Do not deny it. Everything else, allow it. But having said this, this is gig00 out. Remember I said there is something called in and out. In, when the router has not processed it. Out, when the router has looked up the routing table, put it into the memory, looks up into the CPU and everything, and then decides, okay, how this is going to go out. So that interface is basically out. In is when the packet is coming in before the router has even processed it. IP access group, no access out. So basically what this saying, anything which comes in from this gig01 to R1, let him go out through 000. But as soon as this puppy tries to come in from here to this network, block this 11.10, allow everybody else. Commenting a numbered ACL, access list 1, remark. Remark is all they're trying to tell you is a kind of description, right? It's a kind of description which says that, if I'm configuring an access list, I put a remark. What this tells me is that, what is this for? If I've configured something, I put a remark, I've gone home, somebody else has come in. As soon as they look at the remark, they know right away what is this access list for, what it's trying to do. Understood? So remark is kind of description. Do not allow guest workstation through, deny it. Allow devices from all other networks wanting to subnet, allow everything else. Only this 10.10, which is the guest network, don't allow it. Understood? Same thing here, deny, one, permit. If you do on the router, show access list, or on the firewall, it's going to go like this in the sequential order: 10, 20, 30, 40, 50, 60, 70, like that. Extended. Now extended, how did the extended go? Is basically access list. Remember, 1 to 99 is standard, 100 to 199 is basically extended. And it's always source to destination. Source protocol, destination protocol, source port to destination port. So now what this is saying is access list 114, permit a TCP connection from this source network to any destination network equals port 23. Now, if you don't remember what port 23 is, Telnet, FTP, those are the port numbers. And there are 65,535 port numbers. So you go on Google, you're going to look at it. What is this each one? If you put equals Telnet or equal 23, it's the same thing. Router and firewall will understand it, what these ports are. These are the most common ports, right? So they're just showing you that even if you put a port number, it will translate it automatically for you. So that's exactly what they're trying to tell you here. The port numbers will get translated here. Now, extended, what is this? 101 permit IP from any source to any destination. Allow everything from any source network to any destination network. Allow it. Permit all packets, that's what it's saying. Over here, access is 101, deny IP from any source. Because remember, in the beginning is always the source, at the end is always the destination. So deny IP from any source to this host 10.1.1.1. From any network going to this host, deny it. Now, access 101, deny IP host. Remember, as I said before, what I said, always the source and destination later on. So this, if you look at this, deny IP host, which means deny this host to go to any of this destination network. Understood, guys? Understand the logic, how this logic is, and then it will be easy for you to understand this point. What is this? Access this 101, deny a TCP connection from any source to any destination equals telnet, which means that from any source to any destination network, your telnet is not going to be enabled, your telnet session. Because you telnet into a device, you use a telnet and IP address to get on any, because you see in the firewall, when you try to access a firewall, what happened? It's a SSH. SSH is secure shell, encrypted, right? Connection from the source to your jump server to basically the firewall. A lot of routers are basically getting configured with SSH, secure shell. Telnet is not secure, it's a plain text, right? But SSH is basically encrypted. So any connection which goes from your jump server to the firewall is encrypted. That's why it's never a telnet into the firewall. But nowadays, a lot of routers and switches and everything, they all are using SSH connection, secure shell connection, we call it. So this same thing, deny TCP, any source, any destination equal to telnet, means do not allow any of this telnet. Now, what this is, it says access list 101 deny TCP any from any source to any destination. If I'm starting a telnet session, any, so TCP packet whose source is port 23 are denied. Any other source port is allowed. Again, from this network 32, this one equals 20 and 21 FTP and FTP data. These are different ports. If I look at this, access list 103 permit TCP connection from this network to any of the destination network equal HTTP. If I put HTTP, it would have worked. HTTP port number is 80. 103 permit TCP 191.68.10. Any destination network on HTTPS is port 43. So 443 is HTTPS port number. Access list 104 permit TCP any from any source to the destination network established. What established is basically if my behind the router, I'm trying to create a TCP session because TCP is where the acknowledgement comes in. Anything which is start a TCP connection from inside my network to the outside of my network, allow that, establish it. But anything from outside trying to connect, I have a TCP connection, deny it. That's what the establish does basically. Access list 103 TCP any equals this, same thing. But IP access group 103, I remember I said access group, when it goes under the access list interface, it becomes access group. But when the access group means same as access list. I don't know why they call it access group. Make life easy. It should have said access list, right? I don't know. That's how they wanted it. That's how they programmed it. 103 in and 104 out, which means 103 in is basically on R1 gig 00 right here. It says anything which is coming in, you basically on 103 allow it on this, and 103 out going outside of the network. You have initiated the TCP connection. Because why? In a TCP connection, you need an acknowledgement. So any traffic, anything which is coming from the source with the TCP with an acknowledgement, allow it. Understood, guys? This is access list 109, 102 deny TCP, any TCP connection from any source going to this destination network equals 23, and permit IP any. Permit IP from any source to any destination. So basically it's saying anything which a TCP from any source going to this network on 23, deny it. Do not allow anybody to come from here going to this network on a telnet session, deny it. But everything else, you're allowing it. Understood? Same thing here. This is for you basically for browsing. Same concept here. I permit TCP any source established for browsing, because you see for HTTP, basically you need to have a session established and everything, the acknowledgement, right? So that's why you put established connection here at the bottom. That's exactly what I explained you earlier. And you put under here, surfing in, packets coming into this, and out, basically going out. Okay. I'll I'll pick up this NAT. Yeah, there is nothing much. There is NAT and DCP. NAT, I'm going to try to explain to you next class. Yeah, I need to explain this a little bit better so you guys understand what NAT is. Okay, any question, guys? Any concerns? Because this is a big topic, so I don't want to jump on it right now. The NAT. But I can jump on this one. We still got 10 minutes. This is not a big topic. No, this is, I need to explain it better. Okay, I don't want to jump on this topic. These topic, guys, this is a little time consuming. Let me just, can I give you guys a little bit of this? Ether channel, HSRP? Yes or no? Can I explain this? Or is too much for one day?
Yeah, I think it's too much. Let them gas this. Let them try, using this thing or testing this thing on packet tracer. At least they should. I think they should try OSPF and EIGRP on packet tracer.
Okay.
I understand.
So next class will be the last one. I'm gonna cover these 3 topics, and I'm gonna explain it to you guys. Okay. If time doesn't permit, then we will have another class, depending on how many questions you guys will have it. Right? HSRP is a quick one, and because I just wanted to make sure that I teach. DCP is pretty easy, but this NAT one, I just wanted to make sure that you guys understand this NAT. This is important. Okay. No questions? Okay, guys. That's it for today. And next week, Monday will be the last one. Okay. Thank you
Thanks
so
for your time.
much.
Jazakallah.
Okay.
Assalamu alaikum.
Assalamu alaikum.